lecture as a revision of three-dimensional geometry, chapter 11 from class 12th NCERT CBSE. So what I've done is I've taken few assorted questions from the 2025 board papers, and I've taken care that the kind of questions which are taken, which I'll be discussing now, they cover the entire gamut of the question which can be asked. So I've taken questions like find the image. I've taken questions which take care of the parallel perpendicular lines property. I've taken questions which will also cover the skew lines. So what I've done is I've taken these questions from set of 2025 papers, and I think this lecture would be very useful for you because you will be able to revise all the concepts which are used in this chapter. So let's start. And before we start doing the questions, what I'll do is I'll take you through the important formulas which I'll be using in this lecture. So the first formula, and I hope you have basic understanding of the lecture, because if you are a person who has absolutely no idea about this lecture, then you might find it slightly difficult. So I am assuming that you will have some understanding of this chapter. So let's start. So the first formula that you need to understand is the equation of a line which passes through a point x1, y1, z1, and the direction ratios are a, b, c, and c. So this is the Cartesian form in which the equation can be written: x minus x1, y minus y1, z minus z1 over a, b, c. So the point is x1, y1, z1, and the direction ratios are a, b, and c. This is the Cartesian form of writing the equation. Now, you can also write the equation in vector form also. In vector form, the equation is written as r is equal to a plus lambda b, where a is a certain point, the position vector of a certain point, and b is the direction ratios. Basically, direction ratios will give you the angle in which the line is tilted. Another thing which you need to understand is that if I am given a line like this, if I'm given an equation like this, if I take any random point on this line, to find a random point on this given line, what I do is I write this equation of a line, this to be equal to lambda, where lambda is some constant. So to find any random point on this line, x is equal to a lambda plus x1, y is equal to b lambda plus y1, z is equal to c lambda plus z1. So this x, y, z, a lambda plus x1, b lambda plus y1, c lambda plus z1 would be any random point on the given line. I'll be using all these formulas which I'm discussing in this lecture. So before I start the lecture, so I thought of revising few of the formulas which are important. Also, if I have a line L1 and I have a line L2, ABC are the direction ratios of line L1 and PQR are the direction ratios of line L2. Then remember that if they are parallel, then A upon P, B upon Q, C upon R, that is the ratio of the direction ratios would be equal. And if these lines are perpendicular, then if I multiply the respective direction ratios, that is AP plus BQ plus CR, then this would be equal to 0. This is the property of perpendicular lines, and this will be the property of the parallel lines. Again, I'll be using this in this lecture. Now let's look at the midpoint formula. For the midpoint formula, points x1, y1, z1 and x2, y2, z2, let us assume that I want to find the midpoint of a line joining these two points. Then the midpoint would be given by x1 plus x2 by 2, y1 plus y2 upon 2, z1 plus z2 upon 2. So this is how the midpoint formula is given. See, there is another important fact which I want to discuss is direction ratio of a line joining any two points x1, y1, z1 and x2, y2, z2. So the direction ratio of line joining any two points is given by x2 minus x1, y2 minus y1, z2 minus z1. So these three would be the direction ratios of the line, which is joining x1, y1, z1 and x2, y2, z2. So this is an important point. We'll be using this point in the question which we'll be discussing now. Distance formula between x1, y1, z1 and x2, y2, z2 would be x1 minus x2 whole square, y1 minus y2 whole square, z1 minus z2 whole square. And then there's this distance between the skew lines. The distance between the skew lines is given by this formula. Find the image A dash of the point on the line. Find the equation of the line joining A dash. So what I've seen is that this is a very important question, has been asked again and again. So let's variant of this question has been asked again and again in the board papers. So please have a look at this question very carefully. So find the image A dash of the point 163 in the line this. Find the equation of the line joining A and A dash. It is always suggested that before you start the question, you draw a rough line diagram. So the rough diagram that I've drawn looks like this. So this is the point 163. So this point 163 is being reflected on this line x upon 1, y minus 1 upon 2, z minus 2 upon 3. So this is the line which is given to us. And this is the line in which this point is being reflected. So this distance AQ would be equal to this distance A dash Q. So these two distances would be equal. This is the first thing that you need to understand. You might use this in one of the questions. Another thing is that the line joining AA dash would be perpendicular to this line LL dash. So remember that you'll be using the perpendicular lines property. The product of the direction ratios is equal to 0. That property you will be using here. Now, as I have discussed, if I have to find a random point on this line, which line? On this line, LL dash. So x upon 1, y minus 1, y minus 1 upon 2, z minus 2 upon 3, I'll put that is equal to lambda. So x would be lambda, y is equal to 2 lambda plus 1, and z would be 3 lambda plus 2. This is this xyz, this xyz would be any random point on this line, zz, LL dash. Why do I require this random point? We'll see just in the next 2 minutes. So x is equal to lambda, y is equal to 2 lambda plus 1, z is equal to 3 lambda plus 2. Now, consider this random point to be this point, Q. Okay. Now, if I have to find the direction ratios of this line AQ, what will I do? This point is 163. This point Q is this. So I'll just start subtracting the 2 points. So lambda minus 1, 2 lambda plus 1 minus 6, 3 lambda plus 2 minus 3. So the direct ratios of AQ would be lambda minus 1, 2 lambda minus 5, 3 lambda minus 1. So I have found the direction ratio of basically this line. And I know the direction ratios of this line. The direction ratios of this lines are 1, 2, 3. And because these two lines are perpendicular, if I multiply the respective direction ratios of x-axis, y-axis, z-axis, then, so this is the direction ratios of LL dash, 1, 2, 3. This one, 1, 2, 3. Now, if I multiply these, this by this, this by this, this by this, and I add them, this would be equal to 0 because they are perpendicular lines. And I can calculate the lambda value of lambda. Lambda would be equal to 1. And I just need to put this lambda is equal to 1 here. So my point, the Q point would be, if I put lambda here, 1, 3, 5. So 1, 3, 5 is the point Q. So this is this can also be called as the foot of the perpendicular drawn from A to the line LL dash. So Q is 0.135. So this is a 0.135. Now, as I have told you before, I want to basically find the image AA dash. So this image AA dash lies between this distance AQ is equal to this distance, and this is the perpendicular. So Q is basically the midpoint of AA dash. So I'll be using the midpoint formula. So consider AA dash to be PQR. So P plus 1, Q plus 6, R plus 3 upon 2 would be equal to 135. 1, 1, 3, 5. I hope you have understood. P plus 1 upon 2 is equal to 1. Q plus 6 upon 2 is equal to 3. R plus 3 upon 2 is equal to 5. Calculating this, I will find PQR as 107. So this AA dash is the coordinates of the image are 107. Now I have this line A163. This was reflected in a given line, and the image is AA dash is equal to 107. Now find the direction ratios of this point AA dash. Now remember, as I've told you before, the direction ratios of line joining x1, y1, z1 and x2, y2, z2, any line which joins two points, the direction ratios are just you subtract the respective x, y, z. So x2 minus x1, y2 minus y1, z2 minus z1 would be the direction ratio. So if I subtract the direction, if I have to find the direction ratios, I'll just subtract. So 1 minus 1 is 0, 1 minus 1 is 0, 6 minus 0 is 6, 3 minus 7 is minus 4. So direction ratio is 0, 6 and minus 4. And because this line passes through 163, so my equation of the line would be x minus 1 upon 0, y minus 6 upon 6, z minus 3 upon minus 4. So this is the equation of the line which passes through 163 and the direction ratios are 0, 6 and minus 4. So this is my final answer. The equation of the line in the Cartesian form. So this is what they had asked. Find the equation of the line joining AA dash. So the line joining AA dash equation would be x minus, this would be the equation of the line. Now, if I want to check that whether this line, that is AA dash, is this line perpendicular? Is this line AA dash perpendicular to this line LL dash? Then what I do is I know the direction ratios of LL dash. That is 1, 2, 3. So the direction ratios are 1, 2, 3. And the direction ratios of AA dash is 0, 6, minus 4. I multiply them. This would be 0. This would be plus 12. This would be minus 1. And the answer is 0. Of course, it has to be 0 because these two lines are perpendicular. So I hope you found this informative. There is another question which was asked in 2025 where the same question was asked in the form of vector notation. So we'll do this question also. Of the point A212 in the line 4i, 2j, 2k, find the equation of the line joining AA dash, find the foot of perpendicular from point A on the line. Now, as I discussed before with you, it's always advisable to draw a rough diagram, rough figure for you. So, especially in 3D. So, image A dash of the point A212. So, this would be the point A212. In the line, so this would be the line L. So, the first part of the question is we have to find this image A dash. Also find the equation of the line joining AA dash. So we'll have to find the equation of AA dash and find the foot of the perpendicular from point A from the point A on the line A. So we'll have to find this foot of the perpendicular also. So we'll have to find point Q also. So basically we have to find point A dash. We have to find the equation of the line AA dash. And we have to find the coordinate of the point Q. Now, as I've told you, these are the typical questions which are being asked in board papers. So the approach remains the same. There are few things that I will discuss again. One is that this line AA dash would be perpendicular to the given line in which it is being mirrored. This is the first fact. The other fact that I need to review is that this distance would be equal to this distance. And when I'll be finding the equation of this line AA dash, I remember that this line would be perpendicular to this line. So I'll be using the properties of the DRs, that the product of the DRs, the respective DRs is equal to 0. So these are the things which I'll be, will be using again and again when we are doing these image kind of questions. So let's see how this question is being done. So again, because I am very comfortable with Cartesian, so I have reduced this equation. I've reduced this equation in the Cartesian form. So how do I reduce this equation? So this would be x minus 4, y minus 2, z minus 2, and the direction ratios would be, I'll be taking from here. So 1, minus 1 and minus 1. 1, minus 1 and minus 1. So this equation x minus 4 upon 1, y minus 2 upon minus 1, z minus 2 upon minus 1. So this would be equal to lambda. Now, why do I do this? I do this because I want a random point on this line, any random point on this line. Basically, I want this point Q. So using this format, it is easier for me to say that the random point would be given by x is equal to lambda plus 4. Y would be minus lambda plus 2. And z would be equal to minus lambda plus 2. And the random point xyz. So this point xyz is a random point. So what now, looking forward, what I'll be doing is I have the direction ratio of this line. The direction ratio of this line is 1, minus 1 and 1, minus 1 and minus 1. And using the random point, I'll find the direction ratios of this line. Using these only, the random points only. And then I'll multiply the direction ratios, respective direction ratios, and equal that to 0 so that I can find the value of lambda. I'll show you. So I'll multiply 4 plus lambda. First I'll find the direction ratios of this line, AQ. This is the point Q. So this is the point Q. So first I'll find the direction ratios of this line, AQ. So the direction ratios of this line, AQ, is 4 plus lambda minus 2, minus lambda plus 2 minus 1, 2 minus lambda minus 2. So the answer would be 4 minus 2, 4 plus lambda minus 2, minus lambda plus 2 minus 1, 2 minus lambda minus 2. So when I solve this, this is the direction ratio of my line AQ. This is the direction ratio of the line AQ. It has a lambda in it. I multiply these respective direction ratios with the 1, minus 1 and minus 1. 1, minus 1 and minus 1, which is the direction ratio of line LL dash. So when I multiply 2 plus lambda into lambda plus 2 into 1, I will be multiplying these two. Minus lambda plus 1 minus 1, I'll be multiplying these two. So I'll be getting lambda minus 1, minus lambda and minus 1. So this would be lambda is equal to 0. So when I solve this, I get the value of lambda to be minus 1 by 3. And using this lambda is equal to minus 1 by 3, I'll be putting this value here, lambda as minus 1 by 3. So that I get the point Q, this one, this point Q. So when I put the values 11 by 3, 7 by 3, 7 by 3, the value of this point Q is 11 by 3, 7 by 3 and 7 by 3. So finally, I have found this point Q. 11 by 3, 7 by 3, 7 by 3. So let us see where have I reached till here. Find the image AA dash. I still have to reach here. This one I haven't, this is still pending. Find the equation of the line joining A dash. The line is also pending. Find the foot of the perpendicular from line A, from point A on the line L. I have, right now I am at this point where I have found this point Q, which is equal to 11 by 3, 7 by 3 and 7 by 3. 11 by 3, 7 by 3, 7 by 3. Okay, let's go forward. Now I want to find the point AA dash. How do I find point AA dash? I understand that this point Q is a midpoint of AA dash. So what I'll say, 2 plus P upon 2 is equal to 11 by 3. 1 plus Q upon 2 would be equal to 7 by 3. And 2 plus R upon 2 would be equal to 7 by 3. Now I solve this for PQR. PQR is the coordinate of point A dash, which is the mirror image. I solve it and I get the value of PQR as 16 by 3, 11 by 3 and 8 by 3. So 16 by 3, 11 by 3 and 8 by 3. 16, 11, 8. So this is 16, 11, 8. Now I have got AA dash also. Now once I have got AA dash, see, now the things are pretty simple. I have to find the direction ratios. Direction ratios can be found simply 2 minus, I can do 16 by 3 minus 2, 11 by 3 minus 1, 8 by 3 minus 2. And once I have found the direction ratios, then I have this point 2, 1, 2. And I can write this as x minus 2, y minus 1, z minus 2, whole upon the direction ratios, and then I'll have the final answer. So the direction ratios I have calculated here. How I have calculated 16 by 3 minus 2 is 10 by 3. 11 by 3 minus 1 is 8 by 3. 8 by 3 minus 2 would be equal to 2 by 3. So now here, one thing that we need to understand is seems to be some. So yeah, just give me 1 second. So I found the direction ratios. Okay, I have found the direction ratios. Now I can write the equation of the line, this line, the line AA dash, as x minus 2 upon the direction ratio, which is 10 by 3, is equal to y minus 1 upon 8 by 3 is equal to z minus 2 upon 2 by 3. Now see, because these are direction ratios, because these are simple ratios, I can cancel this 3, 3, 3. I can also calculate, I can also cancel 2 1s are 2, 2 4s are 2 5s are. So finally in simplified form, this would be my final answer. That is x minus 2 upon 5 is equal to y minus 1 upon 4 is equal to z minus 2 upon 1. This would be your final answer. If you want to write this in vector form, you can also write this in vector form also. So the vector form will be r is equal to 2i plus j plus 2k plus lambda 4i plus 4j plus k. So in vector form as well as in Cartesian form, this would be the final answer. So I hope this was also useful. And the logic of this question as well as the logic of this question remains the same. This question was in Cartesian form. This question was in the vector form. So let's move to the next question, where almost the same question. They are using some. We'll be using the distance formula. The logic remains the same. Now let's look at the next question. Again, the image question only. Find a point P on the line. This is a line which is equation of a line which is given. So that its distance from point Q is 7 units. Find the equation of the line joining P and Q. So as I have told you before, always helps to draw a rough diagram. There would be a line. This is a line with this equation so that its distance from a point Q. So let us say this is a point Q. 2, 4, minus 1 are the coordinates of this point Q is 7 units. Always remember that whenever they talk about the distance of a point from a line, always remember that this distance is always a perpendicular distance. Between the point and the line, there is always a perpendicular distance. This perpendicular distance is 7. So we want to find this point P, which is at a distance of 7 units from this point 2, 4, and minus 1. Find the equation of the line joining P and Q. Then we'll have to find the equation of the line. Again, to find the equation of the line, once we have found the point P, remember that the direction ratio of a line is given. You can simply subtract the 2 points. So for example, if this is a line, this is x1, y1, z1. This is x2, y2, z2. If you want to find the direction ratios, simply subtract the coordinates. So the direction ratios would be x2 minus x1, y2 minus y1, z2 minus z1. So this would be the direction ratios. It doesn't matter x2 minus x1. You can also write it as x1 minus x2, y1 minus y2, z1 minus z2, z2, because these are the direction ratios. These are just ratios. So it hardly matters whether you are writing this as x2 minus x1 or you are writing it as x1 minus x2. Once you would have found the direction ratios, then you have a point x1, y1, z1. So x minus x1 upon direction ratio 1, y minus y1 direction ratio 2, z minus z1 direction ratio 3. So that is how we will proceed. How we will proceed with this question, and I will show you the solution of this question. Okay. So I have been given this line x plus 5 upon 1, y plus 3 upon 4, z minus 6 upon 9. What I do is, again, like I have been doing in the previous question also, I'll put this equal to lambda. Why do I put this as lambda? Because I want to find a general point on this line LL dash. So this xyz can be any random point. This can be this point, this can be this point, this can be this point, or we will take this to be this point, this specific point where the distance is 7. But xyz is a random point, any point which lies on the line LL dash. So lambda, and then I calculate the value of xyz in terms of lambda. So x would be equal to lambda minus 5 y would be equal to 4 lambda minus 3, z would be equal to minus lambda plus 6. So I have found the value of xyz. Now, once I have found the value of xyz, this point q, p, I know that the distance between the points, I'm sorry, I'll write this as p, because q is being written here, so I'll write this as. Now the distance between p and q is equal to 7. So I'm using the distance formula here, x2 minus x1 square plus y2 minus plus z2 minus, this is equal to d square. So I'm just using the distance formula. So z2 minus z1 square. So I'm just using the distance formula now. I calculate for lambda and the value of lambda comes to be 1. Once I found the value of lambda, I put the value of lambda here. So this would be minus 4, this would be 1, would be minus 3. So my points are minus 4 and minus 4, 1 and minus 3. Minus 4, 1 and 3. So I have found this point as a minus 4, 1, minus 3. Okay, so find the point P. I found the point P. Find the equation of the line joining P and Q. Now I'll have to find the equation of the line which joins these two. So let me find the equation. So first, what I'll do is, the point Q. So first, I'll find the direction ratios. How do I find the direction ratios? As I've told you, you can subtract any 2 minus minus 4 or minus 4 or minus 2. It is one and the same. So what I'll do is, I'll do 2 minus minus 4. This would be 6. 4 minus 1 would be 3. And minus 1 plus 3 would be 2. So these are the direction ratios. I'll repeat. 2 minus minus 4 would be 6. 4 minus 1 would be 3. And minus 1 minus minus 3. So this becomes 3. This is minus 1. So 3 minus 1 is 2. So these are the direction ratios. Now, for direction ratios, you can also boil them down to the basic ratio. So I can also write the direction ratio as, no, I can't do that. So this is 632 is a direction ratio, and the equation of the line would be x minus 2, y minus 4, z plus 1 whole upon 6, 3, 2. Now this is the answer of the equation QP. This is the point. How do I arrive at this equation? So see, this is the point that I have. X minus 2, y minus 4, z plus 1. And the direction ratios are 632. I simply write this as 632. So this was a simple question. But if you see the 3 questions that we have done now, this 34A, 34B, this question, all of these are from 2025 set and are the same kind. The image, you have to find the image, or you have to find the distance formula, or you'll have to find the equation. You'll have to use the property of perpendicular lines. There's another question, a beautiful question, which was part of the case study in, I think, this set 65/4/1. This is a metro line question. We'll be doing this question next. And in this question, beautiful question, you'll be using parallel lines. You'll be finding the equation. You'll be also using the shorter distance between line A and B. You'll be using, so all these concepts are being used. Let's start that question now. So let's start with this question now, this metro question. I like this question because a lot of concepts are being used in this question. We'll do this and you'll understand why this is a beautiful question. Engineer designed a metro rail network in a city. Initially, 2 metro lines A, B, each consisting of multiple stations are designed. Tracks of line A and B. So this is a line A, this is a line B. And now the question which is being asked is, find whether the 2 metro tracks are parallel. So this is the first concept that they are checking. So finding the whether they are parallel or not is very simple. So we'll find the ratio. So 3 upon 2 and we'll check whether this is equal or not. So minus 2 upon 1, 4 upon minus 6. So they are not equal. So that is why they are so they are not equal. So that is why these two lines are not parallel. So find whether the tracks are parallel. No, they are not parallel. So this is a simple question. Now let's come to the second part. Solar panels are installed on the rooftop of metro station. Determine the equation of the line representing the placement of solar panels of the line A dash station, given that the panels are to be constructed parallel. So this is from where our clues start. Given that the panels are to be positioned parallel to line L1. So if they are parallel, then the direction ratios of the solar panels would be this 3, minus 2 and 4 because they are parallel and passes through the point this. So in all this story, what they are trying to say is ki boss, we want the equation of a line which has a direction ratios as 3, minus 2 and 4 and the line passes through the point 1, minus 2 and minus 3. So again, simple. What we'll do is x minus 1, y plus 2, z plus 3. Why? X minus 1 is 1, y minus 2 is plus 2, z minus 3 would be plus 3. And I'll write the direction ratios as here. So this is my second part. Second part is also simple. Let's come to the third part. To connect the stations of pedestrian pathway perpendicular to the 2 metro lines is to be constructed. Yeah. So there's a pathway which is perpendicular, should be perpendicular to the 2 lines, which passes through the point 3 to 1. How do I find the direction ratios of this line? How do I find the direction ratio of this line, which is perpendicular to these 2 lines is, if I am able to find the cross product of these 2 lines, the cross product will have the same direction ratios as would be the pedestrian pathway. So my job is to find the cross product of these 2 lines. To find the cross product, what I'll have to do is I'll have to write these 2 equations in terms of the vector notation. So the first job would be to write these. The first job would be to find the write the equation in vector form, and then we will have to find the cross product. Using the cross product, the direction ratio of the cross product, I'll be finding the direction ratios of the pedestrian pathway. So how do I find the cross product? First, let me write this in vector notation. So I can write this line as R1 is equal to 2i minus j plus 3k plus lambda 3i minus 2j plus 4k, and R2 would be equal to 2i plus j minus 3k plus mu 2i plus j minus 3k. So L1, the vector form of L1 looks like this, and the vector form of L2 looks like this. 2i minus j plus 3k plus lambda 3i minus 2j plus 4k, and R2 would be equal to R2 would be equal to, I think I've made a mistake, 2i plus j minus 3k. I think, yeah, I have made mistake here. This would be I plus 3j I plus 3j minus 2k. So equation of line L2 in vector form would be I plus 3j minus 2k plus mu 2i plus j minus 3k. The cross product of these two, 3i minus 2j plus 4k, 3i minus 2j plus 4k, and 2i plus j minus 3k. So here I am finding the cross product. So this is the cross product that I'll get. Now, once I have found the cross product, then I know that the direction ratios of my pedestrian would have the direction ratios as 2, 17, 7. And that pedestrian pathway would pass through this line, this point, 3, 2, 1. 3, 2, 1. So what did I do? I'll review the facts again. See, these were the two lines that I had. These were the two metro lines that I had. So let me call this A, let me call this B. I found a pedestrian pathway which was perpendicular to both these. To find the line which is perpendicular to both these, I have to find the vector product. Once I have found the vector product, those are the direction ratios. The pedestrian pathways would have the same direction ratios as the vector product. So the direction ratio would be 2, 17, 7. And this line will pass through 3, 2, 1. So the equation of the line of the basically the pedestrian pathway would be x minus 3 upon 2, y minus 2 upon 17, z minus 1 upon 7. 2, 17, 7. 2, 17, 7. The line passes through 3, 2, 1. So this is the pedestrian pathway. This is the equation of the pedestrian pathway. Now the next question is find the shortest distance between line A and B. Now the shortest distance between line A and B, we know would be given by this formula. A2 minus A1 dot B1 cross B2 upon B1 cross B2. So this is the shortest distance between line A and B. So let's find the. This is the vector notation of my line A, 2i minus j plus 3k, 2i minus j plus 3k, plus 3i minus 2j plus 4k. This is 3i minus 2j plus 4k. This is the first line, 1, 3 minus 2, 1, 3 minus 2, and 2, 1 minus 3. This is my second line. Now I have already, so this is A1, this is B1, this is A2, this is B2. I have already found the value of B1 cross B2. See here I have already found the value, this 2i minus 2i plus 17j plus 7k. I'll just put that here. And A2 minus A1, this is A2, this is A1. So A2 minus A1, I'll calculate and put it here. Then I have to find the value, the modulus of B1 cross B2, modulus of this line, 2 square plus 17 square plus 7 square, 2 square plus 17 square plus 7 square. I find the dot product of these two lines. And finally, I get 31 by root 342 as the final answer. I'll share the notes here The link of this video would be mentioned in the description. You can refer to that. So I hope this lecture was useful, and we covered a lot of. This was almost a short revision of the 3D chapter. So we did this question, then we did this question, this question. We did this metro line question, and you can do this question on your own and share the answer. All these questions are from 2025 boards, CBSE board. So thanks for watching. I hope this was useful.